4 in networks. We're still covering networks and topologies. So far we've covered the types of network, LANs or WANs, where a LAN is what you experience in the classroom, and a WAN is a wider area network geographically across the world, so that would be the internet. We've also looked at the things that affect the performance of the networks, and there's quite a few things there that slow a network down, or maybe you can make improvements to how the networks operate. And in the last lesson we took a look at the different roles of the computers, either in a client server or a peer-to-peer network. Now I'll just finish off with client server and peer-to-peer network before I move on. Basically the choices are down to you. This is why we're teaching it, is that you can make an educated choice if you are a consultant talking to a business. So maybe if you're only talking to a very small business with 2 or 3 people, 2 or 3 computers, then you don't need to go into a client server based network, because the cost would be too much. Maybe you'd want to look at how a peer-to-peer network would work for them. And pretty much peer-to-peer networks is what you have in the home. Client-server networks are really for a lot of people. So if you've got 30 or more people sitting on the network, then maybe it's better to have a client-server network. This lesson, we're going to take a look at what we need to actually make that network. So if you go and buy a computer from PC World or wherever it is, as a standalone computer, what else are you going to have to buy to go with it to turn it into a local area network? So this is looking at probably just the home environment or a school. Certainly we're not looking at the hardware for a wide area network, so we're not going to look at satellite launches or anything else like that. So we're going to look at these things: wireless access points, routers, switches, NICs, and transmission media. So what hardware is required to build a network? Well, the hardware is the physical parts. That's the bits you can touch, the wires, the boxes, cables, the computers themselves if necessary. And to create a physical network, and I say physical network because there's also something called a virtual network, which is just in software. To create a physical network, things that you plug together, we're going to need certain hardware to make it go. And there are some fundamental ones that you must have to be able to create most networks. And the most basic of all of this, and probably the cheapest of all of this, is the actual transmission media, the way that 2 computers talk to one another. So we're going to take a look at transmission media first, and there's 2 forms, and we're going to deal with this in more depth later in the course. There's a wired network, or there's a wireless network. The wired one is everything to do with cables, and wireless is everything to do with radio waves. And when we're dealing with cables, there are 3 main types of cables that we can use. We can use coaxial cable, we can use twisted pair cable, or we can use fibre-optic cable. And in the exam you may be asked what the differences or the advantages of each are. If we're looking at wireless networks, which we don't really cover too much in this lesson, that is radio waves, and it includes something called Wi-Fi, which is what you're familiar with, that term, but it's got a very strict definition when we come to computing, or Bluetooth, but we won't deal much with Bluetooth in this course at all. But I'm going to mention it because it's still radio waves. And there's other radio networks, particularly when we come to WANs, wide area networks. You might get 4G or 3G. They're radio networks which are wide area. So as far as this lesson goes, being wide area, we're not dealing with it. So we're not dealing with 3G or 4G. We're not going to deal with Bluetooth too much, mainly because it doesn't form a network. It's just a way of connecting 2 devices together. So let's take a look at the different cables. First one, coaxial cable. I've got a picture of it here. You probably know this better as sort of television cable. So if there's an old style aerial, or if you're using Freeview, you might find aerial cables in your house, and they look like this, and they're made up of the following things. Right in the center is a copper wire that carries all of the data. Now that copper wire needs to be insulated because if it wasn't, all the information would be lost into the outer copper mesh that you can see there. Now that copper mesh forms a kind of shielding, and that is to protect it from any outside interference. So if there's radio waves or anything else like that in the air, or light switches going on and off, that copper mesh filters that out, and the copper wire is safe to carry the data. So that has to be insulated, otherwise they'll touch, and if they touch, then there's a short circuit kind of, and the data would be lost. And the whole thing is put together with some outside insulation. The insulation is just sort of plastic. Now this cable is still used. It's quite a good cable, but it's it's very old. It's been around since the last century, and we've got better ways of actually transmitting data through cables these days. So they're going out of fashion very, very quickly, but it still works really well. And it could be a choice in what you choose for your computers, how you connect them to the network, but we'll see something along that lines a little later on. The one that you're probably familiar with is this one, the twisted pair cable. Now what this is 8 cables running inside some insulation. Each cable contains a single wire, and that wire's got a little bit of plastic around it to shield it from any interference. And also the reason why they're twisted also helps to cut down on the interference that there is. And you might notice there are 8 cables all twisted in pairs to make up 4 twisted pairs. This is the most common kind that you use. All the computers in room 25 are twisted pair cables. So if you cut the end off, this is what you would find. If you cut the plug off, that is. And again, probably in your household, if you've got things connected to your hub, your switch, your router, whatever we want to call it, that's supplied by Sky or Virgin, that will be twisted pair cables. And there's a special connector that goes on the end that you are really familiar with as far as a network goes. You just push it into a socket, it clicks into place. So they're twisted paired cables. The final cable that we use is something called a fibre optic cable. What that is, you've probably seen this on Christmas trees at Christmas time. You've got little filaments of glass, very fine glass threads, and they carry light. So if you look at the end of the thread, it would glow, and that's used in Christmas trees to give sort of all sorts of flashing lights going on. So you see the end, you see the light. When you look at the cable from the side, you don't see the light, but they're very, very thin, they're very, very fine. And this kind of cable is slowly replacing all the cables that are in computers. So it's replacing coaxial, definitely replacing coaxial, particularly on the outside of your house. And it is beginning to replace some cables internally. However, I've not seen many computers for sale at the moment with fibre optic connections. So let's take a quick comparison between these sorts of things. The table at the top left, we're comparing copper wire, that's coaxial, and twisted pair, because the wire inside twisted pair is copper. Now, copper wire transmits data as electrical signals. So it's an on and off electrical signal that's being transmitted, whereas fibre optic, as we've already mentioned, transmits data as pulses of light. So the way that the signal is transmitted is electrical in copper wire, light in fibre optic. Copper wire is very much cheaper than fibre optic, which is why at the moment we've probably got so much of it around. It is really cheap. But obviously as time goes on and computers get faster and networks get more and more used, then maybe the fibre optic cable could become cheaper over time. Fibre optic transmits signals at faster speeds, much faster speeds, and over greater distances than copper wire. Now in one of the previous lessons I told you that as the data was travelling along it kind of deteriorates, it runs out of petrol and you have to refill it to keep going along on your journey. The petrol station is called a repeater. We're going to take a look at this so far. So the table on the bottom right, it says deterioration in range. So if we're using copper cable, coaxial cable, that's got a range of 500 meters. At 500 meters, then you will have sort of got a signal which is deteriorated and you can't read it. It would need to be repeated, amplified and boosted on. Twisted pair cable, well, that's only got a range of 100 meters before the signal deteriorates. Fibre optic, many miles, and we're talking between 40 and 60 miles before the signal deteriorates. So if you're trying to think about what you're going to use for your network and how far you want your cables to run, so in room 25, they don't really go much over 100 meters. But if we wanted to connect directly to the server in Mr. Adams' room at the top of the English block, then maybe we'd think of using coaxial cable instead because it's got a longer range. It's either that or we could use twisted pair as we do and have lots of repeaters. Wi-Fi I'm going to put in here, but we'll deal with Wi-Fi a little bit later on. For a 2.4 gigahertz Wi-Fi, and there's two kinds, there's 2.4 and 5. Inside a building, it has a range of just 46 meters before the signal's lost. If you were outdoors, that would double to 92 meters. So even outdoors with the best Wi-Fi, you're not getting as far as a twisted pair cable. And if you're using Bluetooth, then the range of Bluetooth is only 10 meters. So the minute you go over 10 meters, the signal is beginning to be lost. And if you've got a set of headphones and your phone and you've walked away from it, then you might notice that the sound starts breaking up. Bandwidth, copper cable can have a speed, a maximum speed, if you remember this is kind of the speed limit, of up to 1 gigabit per second. And don't forget with bandwidth, if you've got copper cable and 1 gigabit per second, if you've got two computers, each computer would have 500 megabits available to it because the bandwidth is divided up by the number of computers. If you've got a fibre optic cable, however, then you get speeds of up to 10 gigabits per second, which is absolutely amazing. So if you think about how far you can transmit signals and the speed you can get, the bandwidth you can get, then it looks like fibre optic cable is going to be the thing of the future. But there is something that sort of drags fibre optic down, and that's generally the cost of installation of the cables. If you've got a wireless setup, then you can get up to 600 megabits per second on the bandwidth. But I've got to say that if you've got a wireless computer, then the chances are, and your network in home, that the maximum speed there is only around about 54 megabits per second. This is saying it's up to, so you've got a really strong, powerful wireless transmitter to get those speeds. The differences between sort of cabled and wireless networks. For cable and wireless, the bandwidth, well, you prefer cable because it can get up to 10 gigabits per second if you use fibre optic, whereas wireless is incredibly low, up to 600 megabits per second maximum. And like I said, it's normally 54 with the computers that you use with laptops. So if you're choosing to build a wireless network, please remember that you won't get so much data across the network. You need to really use cable. To install the different devices, if you are doing a cable installation, then that's quite difficult. It's a negative because you've got to run cables through the site. So if you think about room 25 again, it has to go from your computer into the trunking at the back of the computer, which runs along the desks, then up the wall to the switches, and then we have to have cables routed throughout the school. A lot of places have cables that are routed underground, so there's a lot of effort and time digging up the ground to lay the cables. With wireless, it's pretty easy. All you need to do is put a wireless access point in, and we'll look at wireless access points in a minute. The cost of cabling is expensive in comparison to wireless, that is, because you need so much cable. The cable itself is quite cheap to buy a short run of cable, but normally you're buying hundreds and hundreds of meters of it, and that costs money. And again, the installation costs a lot depending on whether you're routing it overhead or you're going through the ground. The last thing you want is cables just dangling everywhere. Wireless again is quite cheap. It's just the cost of the wireless access points. You may have many access points, so one in each room, that would be actually wired to the switch. They're not wireless on their part, they're only wireless from your device to the actual switch itself. Security on cabling is very good. I mean, for example, if you haven't got your computer plugged into the network, nobody can get onto the network and steal information. So a computer needs a socket that you can plug into. Wireless is very, very poor and quite dangerous. So anybody who's in range of your wireless can access the network. So you've got to use security passwords. And don't forget, if people can access your network, 10 people sitting outside of your house, it's going to really reduce the amount of bandwidth that is available to your devices. Interference. Interference is good with little or no loss of signal in a cable because there's lots of shielding. We saw that with the coaxial. There's lots of insulation and there's actual wire shielding to protect the inside copper wire. So the interference is pretty good with cables, and it's not so good with Wi-Fi. So your signal can be lost. In other words, your connection to the internet or whatever you're doing can be lost just by people using electric mowers, electric trimmers, turning radios on, televisions, walls, anything can interfere with the signal, and so it's not so good. Mobility, that's the ability to move it around. If you've got a cabled network, that's quite poor because you actually need to plug the computer into a socket. You can't take the sockets or wires with you. They're fixed in place. Whereas with wireless devices and wireless laptops and your mobile phones, you know that's pretty good as mobility is concerned, as long as you're within range of the wireless access point, you can just move about with your device. So switches. These are the things that your computer connects to. And I've got on the bottom right hand side a pile of switches. They're all doing the same job. It's just that the different switches can take a different number of devices. Obviously the very bottom one on there is probably the best one to use for a classroom because you can plug 30 devices in. Maybe you'd need 2 or more of them to plug more devices into, but your home might only have the one that's on the top, which has got just a few, enough to plug in, what, 6 or 7 devices. The one on the top, I just want to mention that the little yellow one, and this doesn't apply to any of the ones below, but the little yellow one is your internet connection. The rest of them, which don't have a yellow piece of, I don't know what to call it, just a dub of paint or what have you, they are for connecting your computer into there. So you would never connect your computer into the yellow one. That just goes to your internet. Now there are 2 things, switches and hubs. They look identical. So that stack of 4 switches down there could be a stack of 4 hubs. I wouldn't know just by looking at it whether I got a hub or a switch. Hubs are a little bit old and they're replaced by switches. Hubs are not very intelligent, switches are intelligent. And what I mean by intelligent is the fact that if a signal comes through to the hub from somewhere else, it knows, to the switch, sorry, it knows where to send the information to, which computer to send it to. A hub doesn't do that. A hub will get the signal, it might be a video or email message or anything, and send it to all the computers. That means that if you've got a hub that's going to create unnecessary traffic on the network, we're going to have lots of data collisions. That's going to ruin the performance of the network. So they're being replaced with switches, and if it's your choice, I would insert a switch. So switches read where the information's got to go. It looks at the packet. We mentioned packets before as being like a self-drive car. You're not going to drive the car, it's in control itself, you're just the payload, you're just the data inside. But the car needs to know where it's going, and that would be called the destination address. And we use something called MAC addresses, and that's got nothing to do with Mac laptops. It stands for Media Access Control, and all devices these days have a MAC address. It's created by the company who make the device, and each one is unique. We'll look at MAC addresses a little bit later on in this video and again in further videos, but that tells which device we need to send the information to. It uses a MAC address. There's something else called an IP address, which you've probably heard of, and I will tell you the difference between those two a little bit later on in the course. Routers. Now, a router, I want you to take a look at the diagram on the right hand side. We've got a file server at the top, printer, a laptop, then a game console, spouse's desktop, internet enabled TV. They all connect to a switch, and the switch itself connects to a router. Now the router's job is to read the information and send it to the correct network. Now you may have many networks in a school, may have an admin network, may have a student network, may have a network for visitors, all separate networks, and the router would know which network to send it to. The switch knows which computer on that network to send it to. Now, the thing is, switches and routers and hubs, they're all combined these days into one item, and I've sort of given you an example at the very bottom. And again, you can see that we've got 4 inputs for wired connections and a yellow one for the internet connection and a couple of aerials for the Wi-Fi to connect to it. But this would tend to be a combined item, that's a router and a switch. So it connects all the computers together and can send data to the right computer, but also can route on information to the correct networks. You need to be aware that routers and switches are different things, and we lose the distinction when we're buying them, because a lot of them these days are combined routers and switches, but essentially they're very different things. To be able to connect to a network, you need a network interface controller, a NIC. Sometimes it's called a network interface card, or it used to be called network interface card, because it used to be, as you can see, the large green sort of motherboard items attached. it used to be a card that plugged into your computer. Not all computers came with the ability to connect with a network. You had to put a special card in, and I've shown you at least 3 on that slide there, and they all do different things, but you used to plug that into your computer, and then you could plug the network cable into that card. So it used to be called a network interface card. It's now called a controller because so many different devices can attach. So starting at the very bottom left hand side, we see one there that can take either twisted pair cables with the little square plug on the right hand side of it, or it can take a coaxial cable. So it's got a rather large sticking out sort of socket to plug in like a television aerial, the coaxial cable. Next to that on the right is a sort of a USB version with the network interface controller. And many computers these days, and the laptop that I'm working on is a case in point, it does not have an external socket to plug into the network. And I would want to do that because I can get speeds of up to 100 megabits per second if I was wired to my network rather than use 54 megabits per second on the wireless. So making these videos and transmitting them would be a lot quicker if I could actually hardwire my computer into the network. To the right of that on the bottom right, you see a card with just an aerial. So that would be to stick into your computer to turn your computer into a wireless network installation. Now, wireless network installations, another benefit of them is sometimes if you're running an office in what we call a grade 2 listed building, meaning that you can't make any alterations to the building, you probably wouldn't be allowed to actually start putting cables inside the walls, etc. And the only way you could connect would be wirelessly. So even though computers can connect to the network using cables, you might have to use wireless because of building regulations. The one above or between the two, the bottom two right-hand sides has got a single socket on there. That is what I would call a normal network interface card that you just plug into the computer and you plug the socket into the hole there. And the one at the very top right is another network interface controller. It's a wireless that you just push into the USB port and your computer can handle it. Now, most computers have got the circuitry on board to make these work. If they don't, then you would need a card to make it work. A wireless network device is also called a WNIC for wireless network interface controller. I mentioned MAC address earlier, and every NIC, so every device has its own media access control number programmed onto it. That's done by the manufacturer. And it looks like the example below. It's a load of hexadecimal numbers. In fact, it's 6 of them. I've got here 3A, 3452, C4, 69, B8. There are enough of those to cover every device that is manufactured in the world. And if you want to have a look on your phone, you'll find that your phone has a unique MAC number, which is how the network knows where to send the data to. So when you connect your phone to the network, it gives it that address, that number, and then anything that needs to go to that device, the router and the switch can make the information go there using the MAC address. Finally, we're going to look at wireless access points. We've seen how to make the computer become wireless by putting a card in or a little USB controller. But to be able to connect to the network, you need to have an access point. Sometimes these are called hotspots if you're in a public building. So if you're in town and you're using the Tesco's Wi-Fi, they're called a hotspot. And on the bottom left is what we probably normally see as a wireless access point. In room 25, you might find one of these on the ceiling. But there is a wire going from that to the actual hub or switch. It does not transmit wirelessly to the hub or a switch. It needs a wire going to it. but everything that connects to the switch goes through the wireless access point if it's wireless connected. So what they do is that they convert data from a switch into wireless signals and send them out to your devices, your phones or your computers, and vice versa. Your device or your laptop will send a wireless signal to the access point, and that will convert it into a signal which can be used for the switch. Now, wireless access points act like hubs. They don't look at the individual device and send the information to it. Be pointless really, because it's just radio waves. They just broadcast everything out, and only that device with that address will be able to pick up and use that message. So like an old-fashioned hub, it's just broadcast to every single device that's connected to it, but only the device that needed it will get it. So that's the end of our look at the hardware. In future lessons, we're going to start looking at how they work together, how they send the binary information around the network.